Joining you today, this is Molly Presley. I'm responsible for product marketing here at Qumulo. And joining me is Ben Gittenstein. He's our VP of product, and we'll be really working together to share with you where Qumulo sees the future of flash storage going in file-based workflows. Just a few housekeeping notes. This event is being recorded, so if you have any concerns with that and need to drop off, feel free. We'll be sharing the recording with the registrants after the session as well. And if you have any questions, we'll be handling Q&A at the end, so feel free to use the Q&A button that's part of the Zoom webinar, and we'll pick up those questions at the end. So good morning, Ben. Can you hear me okay?
I can. Can you hear me okay?
Yes, sounds great. So what we're going to do is take about 20 minutes of your time today and talk through really the trends that Qumulo is seeing affecting the usage of flash in the file storage market. There's the technology evolution, the types of NAND that's coming out of the market, but then there's also just supply chain and pricing that has been affecting how Qumulo is adopting flash and our different technologies. Ben, maybe would you talk a little bit about what we're seeing on the market itself, the supply chain, and how you've thought about that as you start to put together different architectures for Qumulo?
Sure. Yeah, and thanks for including me. I'm really excited to talk to everybody today. You know, when we think about flash, I'll tell you, when I started at Qumulo several years ago and we looked at the flash market, back then we said, wow, this is a really exciting set of technologies that we are very excited to leverage, but it seems economically out of reach for most customers, for most workloads. And that was really driven by a couple of things. It was driven by the supply of flash, just the amount that was available. And it was driven by the types of flash that were being made, whether it's about the way the flash connects to the rest of the system, i.e. NVMe versus more traditional methods, or the way the flash itself is constructed, the number of layers, for example. All of that sort of looked different than it looks now. And the way that played out was we would talk to customers, and customers would always come back to us and talk about the multiples. They would say, look, I am really interested in the idea of flash, but as long as a gigabyte of flash on your product is 10x the cost of the same gigabyte stored on a standard, 7,200 RPM or 10,000 RPM 10,000 case hard drive, then it's really hard to imagine how I use that in the rest of broadly in my data center. We'd find sort of niche use cases where it'd be interesting, but it was pretty hard. And then all of a sudden, the world changed, and it really changed very rapidly. There were a couple of things that caused that change. The first was all of a sudden the supply of flash grew really, really fast. The number of fabs required to make flash shrank, and because the fabs became more efficient, and there were just all of a sudden a lot more fabrication plants. And then the world shifted to NVMe, and relatively quickly, the world said, oh my gosh, NVMe is better than SATA, and all the fabs being created either were built for NVMe or shifted all their machinery to build NVMe SSDs. And then the last big shift that changed was the emergence of basically more dense flash, and more dense both in terms of the number of gigabytes or terabytes on a drive or on a chip, and also the layer density, going from 2 layers to 3 layers to 4 layers, what some people talk about QLC drives. All of that led to just a rapid change in the economics of flash. And one of the most interesting things that happened in that pricing war, by the way, was that the folks that had built QLC plants and the folks that had built TLC plants, so people who were making a triple layer cell flash versus 4-layer, quad-layer cell flash, started getting into a price war with each other, because if you'd built a very expensive TLC plant and you had machined all your products to build TLC flash, and then somebody next to you builds a QLC plant and is building QLC flash, well, they're going to steal a bunch of market share for you, so you're going to start competing on price. And all of a sudden, from our point of view, what that meant is like, well, these are all just flash drives to us, And all of a sudden the price of a gigabyte of flash just started to fall. And for us, that looked like a really interesting democratization moment, because all of a sudden it was like, oh, wow. So this thing that was really unavailable to most customers for most use cases starts to become available to a lot of customers for a lot of use cases. And that gets really, really interesting, because now you see the crossover point has been reached on NVMe versus SATA. You see the crossover point has already been reached on SSD versus some forms of hard drive. And then you see the multiples shrinking materially. Now, what that says to me is that I don't think hard drives are like going away. We're not going to, for example, at Qumulo, we're not going to jettison our hybrid product. I think for large at-scale workloads and for customers with certain price points, that they'll always, in the time frame that I know how to think about, they'll always be valuable. But all of a sudden, flash becomes a lot more interesting to a lot more customers. And then it becomes our job as Qumulo to pass that value on to the customer as fast as possible, to democratize flash so that anybody who wants to use it for a workload has that opportunity.
So I think then that's a great topic to just, before we jump into a little bit more about how our software leverages flash, as technology companies, we all have access to the same flash drives, similar pricing. You mentioned passing this on to our customers as soon as possible. Maybe if you could just touch quickly on how do we get the technology into the hands of our customers fast, and then a little bit about our pricing model and how we think about software versus hardware pricing, because that's pretty unique versus the way a lot of vendors sell appliances.
Yeah, I mean, those are two really good questions. So the first one being, how do we pass that value on to customers? And the second being, how do we think about pricing? So they're both tied to a very fundamental principle here at Qumulo, which is we think it's our job to build great at-scale hybrid cloud file products, and we do that as what is predominantly really a software factory. We hire software engineers, we build software features, and we architect our software to run wherever customers want to run it. Obviously, we put constraints on that because data safety and integrity is really important to us, so you can't run it on just anything. But we try to make it as portable and flexible as possible. One very tangible way that plays out is we made a very specific architectural decision early in the life of the product not to rely on non-volatile RAM, on NVRAM, which NVRAM is just one of those things that you pretty much always have to machine yourself. It's pretty hard to get commodity NVRAM. And once you go down that road and you start building software stacks that assume NVRAM, it's really hard to unwind your product from those sets of decisions. And there's two places you're never going to find NVRAM. You're never going to find NVRAM in standard hardware, and you're never going to find it in the public cloud. So that fundamental decision early in the life of the product really enabled us to be flexible. So what that means from our point of view is, to your first question, we spend as much time and energy as possible when it comes to platforms on picking great platforms that give great economics to customers. And we pretty much pick them right by just talking to the distributor. We don't do any machining or creation of hardware. We just pick those things. We spend a lot of time on testing to make sure that hardware is safe. We have little robots that go and pull drives and create power events and brownouts and stuff to make sure that the hardware is data safe. But assuming that all of that works, and usually it does, and if it doesn't, we reject the platform. But assuming that all of that works, we're really just taking our product and bringing it up in that environment, which is a very simple process. So what that means for a customer is that we can relentlessly qualify new hardware configurations. So as an example, we have released, I think, somewhere between 4 and 6 new hardware configurations in just the last 4 months, where it doesn't exactly map out to a configuration a month, but it gets pretty close. And the reason we do that is, honestly, we spend more time internally arguing about how to name the thing and what the exact launch plan is going to look like than we do on bringing the product up. Because we have built a software product that is meant to adapt to those new hardware offerings as fast as possible. Now, your second question was about pricing. There's two fundamental truths here that we want to live by. The first is we want to push all of our value as a company into the software and support that we sell. Because when you become a Qumulo customer, there's two things that you really get the most, where we focus our value, which is delivering you new features that create more value for the product that you're using, and delivering you a great customer success experience so that you always have somebody to talk to and we always keep you up and running. So that's where we focus our value and energy. And then the second truth we live in is customers want to acquire our product on a lot of different platforms. Now, sometimes that means on branded OEM platforms like HPE, but it also often means on platforms that are branded Qumulo. And there's a very simple reason for a customer to do that. It's really easy. You issue us a purchase order, you now have our product we come and we deliver it, we rack and stack it, it's up and running within 2 hours. You've got a file system ready to go at several petabytes and delivering many gigs a second of throughput, and you're up and running, and it looks to you like a single appliance. Now, in that model, the way the pricing works is pretty simple. You pay for the hardware and then you pay a subscription for the software, and just from our point of view, the hardware is really just sort of a pass-through. We buy it from a distributor and then sell it to you at a tiny little markup, basically to cover freight. And then where we ask for value is in the software we create that you use every month. So that's how pricing works in our product. And if I was allowed to show you our books, you would see that over the last 4 years, the dollar value of our software and the margins we get have all shifted materially from selling hardware, which it was very early in the life of the company when we were really just sort of a stealth product, to now where we are today, where the vast majority of our economic value is in the software we create.
And that's pretty unique. I think, there's the frustration from kind of the legacy vendors of vendor lock-in, when it comes time to upgrade your hardware 3 years down the road, there's big service contract increases. There's a lot of things that can be frustrating for companies that build tight appliances from an economics perspective, but also just the time to getting new nodes out. That Qumulo, we released our NVMe flash nodes for the first time, I think back in 2017, where a lot of other vendors are just bringing them into their technologies today. And it's that software-defined architecture we have that really helps us to do that. And it's really just for us all about getting this technology into our customers' hands, into your workflows as quickly as possible. And we hear time and time again from our customers how important that is to them. I think that one other topic as we think about this, as the customer's thinking about this, and I know some of our existing customers are on the phone today, how do they adopt NVMe into their existing clusters? So we bring out these, you mentioned we've launched several new platforms this year. They've already got a cluster running maybe on one of our other flash arrays or in a hybrid world. Kind of how would they embrace bringing in these new architectures into their environments?
Yeah, I mean, it's interesting. I used to think when I first got here that there were sort of 3 segments in the in the file market. There was the ultra high performance stuff. There was the, active or deep archive stuff. And then there was the middle tier, which was things that were big and fast. Increasingly, the changing economics of flash, which is just a fancy way of saying that flash is getting a lot cheaper, really means there's really only 2 segments. There's stuff that goes fast all the time, and there's stuff that sometimes goes fast and a lot of times doesn't. So there's really like those two segments. The stuff that goes fast all the time and will go fast all the time really should be on one of our NVMe products. The stuff where you have a smaller working set as part of a larger much larger data set really should be on our hybrid products. And then we have really good data movement technologies to move data back and forth between those clusters. There's another point to be made there, which is we'll talk about this a little bit later, but when you think about our hybrid products, and here when I say hybrid, what I mean is, oh yeah, this is a good way to look at it. When I say hybrid, I'm not talking about hybrid cloud. I'm talking about a flash first technology where you have flash in front of disk. We've spent a bunch of time and energy building a product that is intelligent about what lives on flash versus what lives on disk, which means that when you put together, for example, several 10 nodes of one of our flash first products, we pool all that flash together, so you're actually buying several terabytes of flash. That is the landing pad for writes, and it's also where we try to get the vast majority of your reads to come from. So that's why, but that really needs to be sized to your working set. And if your working set is is pretty big, then you really should be thinking about NVMe. So that's how I would sort of divide it up. This page is a pretty good way of looking at that. You can see how our products go from left to right. And increasingly, what's super interesting is as the price of all flash goes down, that highlighted box on the left, I think we're going to see more and more customers and use cases that were in that mixed bucket in the middle. They're going to shift to the left just because they're.
Yeah, and I've seen.
Go ahead.
I've seen from some of the orders that are coming in that the things like we're in our hybrid environments, we've sized the cache for a fairly active environment, but then you start to look at machine learning and analytics, and there's cases like that where even a fairly large cache in our hybrid arrays is starting to make more sense with those really active workloads, push them into the all flash system and then have a cheap and deep active archive next to it. Is that kind of what you're seeing as well?
Yeah, I would say there's a couple things going on there. It's a really good point. So when you think about use cases, so let's take a couple of examples. You're streaming a 4K video to a high-end client, and you want to do direct playback off of central storage, not like a direct attached storage array that's sitting underneath the editing bay. That's a great use case for an all-flash product. You can serve that from one of our hybrid arrays. We've done software work to make that possible, but the all-flash product is just built to be they're throughput machines, and they're just really good at that. You have an IoT. You have a manufacturing workflow where you create products, and you are constantly capturing data from that lands on a storage array, and then occasionally some parts of that get analyzed, whether you're doing machine learning or failure detection and analysis, those kinds of things. That's a great use case for one of our hybrid products. Because really you're talking about, I'm going to have petabytes of data, but my working set's going to be pretty small, and it's a little hard to predict what my working set is going to be. That's a great use for our hybrid products. And then I have like longer term retention stuff that's going to sit there for a long, long time. That's a great use for our archive products. The other is, of course, data protection. I have an expensive production tier flash cluster that's serving my 4K editorial, but I don't want everything to live there. I want my backups and my safe second copies and my DR to be somewhere else. That's a great use of our K-series products.
Yeah, makes sense. So thinking about the software and how we're using flash in our platforms, whether it's for storage or it's for caching or even up in memory, this chart here, our fantastic data scientists in your team pulled for us, and it's I'm sure you've seen this before, a look at our fleet of users across the globe and how their workflows are being read off of their clusters, how much is actually being read off of disk versus cache or out of memory. Can you talk a little bit about our caching architecture and how we take advantage of the fastest storage or the fastest memory in the system as optimally as possible for any workload?
Yeah, sure. So, I mean, at the end of the day, there's two ways to look at performance, I think. The first is about economics, and the second is about sort of frustration. The economics is, how do I paid a certain amount of money for this storage array, how do I get the most performance value per dollar out of that array? And the second is more emotional. It's like, hey, I have users who are going to call me when things aren't working, and often that's because of performance. How do I minimize the number of those phone calls by making them as successful as possible? Nobody notices the plumbing until the plumbing's not working. That's like an often heard analogy. This chart on the right is basically saying, like, look, if you take the sort of 95th percentile millisecond to return an operation, i.e. latency, across different tiers of memory or different tiers of media, so memory, RAM to SSD or flash to hard disk. Obviously, the fastest stuff is always going to be from memory, and then from SSD, and then from disk. And the blue bars are really what percentage in our fleet do we actually observe coming of operations do we actually observe coming from those different media. And what you're seeing is we are able, even though we sell hybrid systems and all flash systems, but even though we sell both of those, and obviously because hybrid systems are so big, the vast majority of the because we're selling 12 and 14 terabyte drives, the vast majority of actual available space or stored capacity in Qumulo across the fleet is much more down in the hard disk range, right? Because we sell big petabyte scale systems often. Those, even though that's true, you're looking at like 70% of our reads are coming from either memory or SSD, and the way we achieve that is. Which means that even though you own a hybrid cluster, it feels like all flash. And when you own an all flash cluster, you're actually as often as possible trying to read from memory, which is even faster than SSD. The way we do that is really two pieces of tech. The first is prefetching into RAM, or memory. So that's how we really do it a couple different ways, but it all is basically like learning how a client is accessing a set of files. So the system watches your access patterns and says, for example, oh, you read the first 5 files in this directory, and based on the directory entry order, so how the directory was created, that means you're very likely to read these next 8 files. We will prefetch those files into memory. The other thing it'll do is, oh, within a file, you read these offsets. So let's go prefetch these other offsets that are very likely to be read. And then it'll prefetch those into memory. And then the last thing, it'll also do that basically also on the name of the file. So a lot of workloads that we serve have very known heuristics for how they name files. So if it's a genomic sequencer or an IoT device or an electron microscope or a video editing software, but you'll often see things like frame1.file, frame2.file, whatever. If you read frames 1 through 4, we'll prefetch frames 6 through 10, all into memory. So that's how we get a lot of the memory reads. And then the last piece of tech that's in there that I think is super interesting is that the system watches the prefetch success into memory. And when the prefetch is unsuccessful, it will turn itself off, because the one thing you really don't want to do is waste memory, because memory is so precious. If the system is not using memory efficiently, it'll stop trying to prefetch and let the client's explicit order take over. The other piece of tech that we built that's relevant here is how caching works. So in our system, whenever you write to a Qumulo, no matter what style Qumulo you bought, the writes always land on SSD, which allows us to give as low latency as possible SSD commits. So the write will have the lowest latency possible. Then we slowly trickle that data down into hard disk based on access patterns. And what we're really looking at is heat, how often that data is used. There's one exception to that, which is all of the metadata in a file system, so attributes, permissions, all that sort of stuff, gets pinned to the SSD layer in your system. So that will always be there, and that works even with very large clusters with high file counts. The next, and then by the way, what that enables you to do is, first of all, the vast majority of operations in a file system are metadata operations, just in count. So that gives you low latency metadata operations. The other thing it lets you do, oh, and you can see how this is reflected in our general latency across the fleet. The other thing it allows you to do is, because we're observing heat, as a file has moved, once a file or it's really a block has moved down to disk, if it's being read a lot, it can be easily promoted. The system will promote it back up to SSD so that you get SSD level performance. With one exception, which is that if the access pattern is showing a nice big contiguous read where you get the real benefit of hard drives, which is you're not wasting time with those disk head seeks, which is where hard drives really struggle, but you're getting the nice streaming throughput of a hard drive, then we'll leave that data on disk. But for the most part, what that means, which is great for customers, is you get the density value of disk and you get the performance of flash. Now, we're not the first ones to come up with that concept. There's lots of great products out there that have thought about the notion of hybrid, but I think our special sauce, our claim to fame, is the intelligence with which we do it, the rapid product development which we do to make that awesome and possible, and then coupling that with enabling standard hardware, because what really gets valuable is when you can take an intelligent system that uses disk and SSD together and use standard SSDs and standard chassis, as well as really, really dense hard drives. Now you're starting to give what I think is really a disruptive level of storage capacity and performance value. And then what you're seeing here
Definitely. One thing I was going to mention on that is kind of, as you're talking about that differentiation, kind of how other vendors have approached it, where Qumulo is unique. I think it's worth spending a minute or two talking about, we are a file storage company. The importance of our NFS and SMB stack in this whole environment is you're thinking about latency and performance coming into an NFS share, for example, and what we've done there to keep that low latency and high performance as well.
Yeah, I mean, just to add on to that a little bit, we're a file company. We believe in file. We think file has real value for customers. We're not trying to be a block company. We think there are some interesting uses for object, but for the most part, we think a lot of why people are sold object products is really to be able to get they have unstructured data and they want that at scale and at a decent price point. And we think that's a great use for our product. But one of the central tenets of our product is that it's a distributed system that can get really big and really fast if you want it to. And the way you do that is you build really high quality NFS and SMB protocol servers, and then you build those in a distributed way so that I can always just add more nodes, and those nodes are aware of each other. That's actually, I say that really fast, but that's a ton of work, and it's a really hard problem to solve, because it means you need to solve the problem of one user is talking to node 4 and they're doing a bunch of reading and writing to a file, but a user comes over node 22 and they talk to that same file. By the way, one of them is on SMB and the other is on NFS. How do you manage the permissions, and then how do you also manage concurrent access across distributed nodes? Not a simple problem. And it's also a place where, to be frank, if you don't build those protocol servers yourself, then you are at the mercy of Samba or whoever else you use. And we take a pretty hard line that these things need to be built ourselves in order to be great. We really want to control our own destiny there.
So enterprise ready to plug in to the NAS environment, and also a NAS file system that is fast enough to take advantage of NVMe and some of the flash technologies, which, people even in the last year or two, that's a big shift, where you would have thought you needed block storage possibly to even take advantage of this really fast hardware. And the file system that has been built is really able to and present that in a low latency way through those protocol stacks, which is pretty amazing. I know in the latest release, we just announced a new all-flash platform based on NVMe about 3 weeks ago. And there were some other optimizations we did specific to flash to continue, thinking about not just the performance attributes that we've already talked about, but a little bit about, memory utilization, the kernels we're running on. Maybe you can talk to us a little bit more about this specific to all Flash performance in just the last couple of releases of our software?
Sure. If you become a customer, you get access to a really rich Tableau notebook that will show you. We have a value here on our. It's actually painted on our wall, not far from where I'm doing this call from. That says we share by default. So we believe in being really transparent about all the decisions we make and all the products that we build. So you get access to a lot of our performance data. And what you would see if you were a customer is you see a pretty significant increase in in particular, write performance of our all-flash product. And there are really two pieces of software, two software changes that drove that. The first was we took advantage of some new capabilities we run on top of Linux in a Linux kernel update that by taking advantage of those, we saw a much more efficient write path, and that generated a big bump in the write performance that a customer can get from our all-flash product. The other thing we did was one of the biggest problems in storage in general, I'm sure folks on this call are aware of it, is the management of CPU. And because the CPU can often become a bottleneck, really because the CPU has to perform a lot of actions, but one of the actions it has to perform for a product like ours is memory management, in the sense that, like, when pages in memory are being used or changed or refreshed, the CPU has to do work. We went and wrote our own system for managing memory, and there is a system that Linux offers. We decided we thought we could do something more interesting, so we built our own memory management system that massively reduced the load on CPUs for memory management. Well, a more efficient use of memory in an all-flash product means you're also going to see a big performance improvement. In this case, it's also in both reads and writes. A lot of that is in writes. And one of the reasons these both come back down to writes is that anytime you write to a distributed file system, you have to do a fair amount of work, because I write to node 1, and then I've got to advertise to the rest of the nodes in the system that this new data exists in the product or in the system. So the more efficient that you can make that, the more performant your system is. There's only one other thing I'd highlight, which is the cool thing about that is that a customer just takes an upgrade and their product just got a bunch faster. And so we get a lot of feedback that we get is from customers who are like, hey, I bought this, a year ago, and I was servicing these set of workloads, but I was really scared to service this other one. Then I took these upgrades. Now I'm serving this whole new class of workloads. And you basically just reduced the dollars per performance of your product by 10 to 40%, which is pretty fun. So
yeah, that's definitely huge. All the features being included in our software as part of a just standard license, no extra charge for the features, is great. But these kinds of optimizations and improvements as they roll out from the team, just automatically being part of those upgrades, definitely adds huge new value to our users. I put up a slide here just to illustrate more from the user perspective, how they can visualize all this that Ben and I are talking about. That we've been showing you aggregate across our customers and across our benchmarks, the kinds of performance improvements we've been making, how Flash is affecting our portfolio. But we have a great tool for our customers to be able to look at their specific cluster, their specific environment. Ben, do you want to talk through just a little bit more about how our real-time analytics uses that data as it's getting cached, and as we start coming, kind of how do we do it for real, like sub-second, real time, and how users can take advantage of these dashboards that we have for them?
Yeah, sure. So, as a value proposition, it's really important to us to give customers insight into how their storage array is being used, because that's how you make better buying and workflow design decisions. That's how you get more value in your business. So, we share by default how the product is really doing and how your workflow is really working. There's really two types of analytics you get in our system. There's performance analytics and capacity analytics. They both rely on a set of foundational technologies that are around, assume that you have a several petabyte system with 1 billion plus files in it. How do I return information on how that system is being used really fast? The answer is you use, first of all, you need to own all of the pieces of your product where customers are doing reading and writing. So in our case, that's owning the actual protocol stacks and having written them ourselves. And then you need to, in the case of performance, you need to watch those things really carefully and marry information about reads and writes with information about the file system and then display those in real time. So what we do is we show you what are the hotspots in your file system for both in terms of IOPS or operations and in terms of throughput, which lets you understand which directories are hotly contended and which ones are not. The other thing that we do is we show you a bunch of real-time analytics around your capacity. Are we going to look at that one? Is that one next? I don't want to talk about it for going there.
No, I didn't. I just captured one screenshot to kind of give a feel for it. I didn't put a slide in on that.
That's fine. So the thing about capacity analytics, which is a little bit different, is, hey, if I have 1 billion files in my file system and I want to understand how big a part of my file system is and whether or not it's growing, that's a really hard problem. The way, and I want to do that in real time, that's very challenging. So the way we solve that problem is that's less about understanding the protocol stacks and understanding how performance is being allocated across the system. It's much more about understanding capacity growth and capacity usage. So what we do there is we took this, in both cases, we took a strong opinion that tree walks are what cause a lot of the problems in analytics, because when you have to scan from top to bottom a file system that is large, both in capacity and count, then you get really slow response times. So instead, what we do is we build a constantly up-to-date index that lives in the file system. It's actually a B tree that is propagated with information about the file system. We call these things aggregates. So these aggregates, they aggregate information about any given directory, and they say at any, for this directory and everything below it, there are 110 million files in here that take up 115 terabytes worth of data. I just made that information up, but that gives, and then we return that to customers in real time. Because there's really, at the end of the day, there's two things you pay for when you pay for storage. You pay for performance and you pay for capacity. And the more insight we can give you into how both of those are being consumed, the better decisions that you'll make.
Definitely. And this is not always, we don't typically go to market really talking about ourselves versus our competitors. We have a new modern architecture, but as Ben talks about tree walks and he talks about how important it is to utilize and visualize how your capacity and performance is being utilized, it's also really important to have an architecture that can take advantage of everything you've bought. As you look at this comparison, this is on the right-hand side, you're seeing a Qumulo cluster that's running right about 100% capacity, 98.1%. It was being used when this snapshot was taken. The importance of what Qumulo does is not just being efficient within the file system, but every single terabyte of provision storage that you have, you can leverage. You won't have issues with dropping performance as your file system gets full. You won't have issues with being able to do system maintenance, upgrades, any of those types of tasks. And that's been kind of one of those things that have been really plaguing the industry. And as you think about investing in more and more expensive technologies and putting all flash architectures in your file system, being able to use everything you buy instead of having that 20, 30% that has to be reserved for kind of system tasks is a big shift in modern technologies, modern file systems that we've implemented. Ben, I don't know if you have anything else you want to comment on there, but I think this is one of those more difficult things to tease out for a user as they're going through the buying process and trying to look apples at different systems. The fact that you can use everything you buy, I love the way our CTO talks about, or our CFO talks about it. It's kind of like, you wouldn't buy a car and only be able to use 2 of the 4 tires. We really expect to be able to use everything, and that's kind of the mentality of Qumulo. And something we just like to continually emphasize to our customers as another value we're bringing in our architecture.
Yeah, I think you said it really well. There's only a couple of other things I guess I would sort of add to that, which is, I think that storage economics are sort of funny because they're not very transparent. And that makes, I think, buying decisions in storage harder than they need to be. And there's really, especially when it comes to hey, how much am I paying for and what am I getting for that? It shouldn't be really as hard as it is out in the world. And I think there's a couple ways it gets difficult. One is the constant games that vendors play with data reduction, like, your X to one data reduction, which boy, is that a dangerous thing to build a quote around, or to build a TCO model for your boss on. And then the other game that gets hard is how much do I actually have to buy in order to serve that data set? And the challenge there is that, well, let's say I have a petabyte of data that actually needs to get used or worked on or stored. And it's hard for me to predict which parts of the petabyte are going to be most often used, but I have about a petabyte of data that I need to actually get used. Well, does that mean I buy a petabyte of storage, or do I buy a petabyte and a half because you're telling me that I can't actually, that if I fill the storage all the way up to 90%, then I get a hard to predict, performance and availability. Like that, then I really shouldn't buy a petabyte. I should buy a petabyte and a half. And the other thing is, like, I have a petabyte of data, but my file sizes vary, and some of them are really small. Well, how efficiently is a small file stored? Because if a small file is stored really inefficiently, then I don't actually need to buy a petabyte. I need to buy more than a petabyte because of your inefficient way of storing data. So our point of view is, look, if you pay us for a petabyte of data, you should be able to use a petabyte of data, and we shouldn't really be, and that should be irrelevant to how full the cluster is or how small your files are. You should just get a petabyte of data. And if you're not getting that from your other vendors, then I think that's a good question to ask them.
Yeah, and as we wrap up, I think that just leads in really well into just the broad set of use cases that we're seeing the Qumulo file storage adopt across, and that you can see here is everything from machine learning to healthcare, PACS types of systems, big video streaming environments. And what Ben's talking about is on the small file handling, on the efficiencies, is really why we're seeing such broad market traction. Is we're fast enough to handle those really data intensive workloads. And then we're optimized for very different mixed IO, mixed file size environments that we can be efficient no matter what the workload is, kind of how your applications are writing data. We spend a lot of time optimizing across those use cases. And so that's where you're seeing this really broad adoption across different types of use cases, different types of application environments. As we tie things up, I have asked Ben a couple of the questions that were typed in through the session. There was one other question that came in that didn't really fit with the flow as we were talking, so I wanted to pose that to you now, Ben. And then if anybody else who's still on would like to type in any questions, we'd be happy to answer those live. But Ben, there was a question about how do we use NVMe in a cloud type of environment? Kind of what is our thoughts on the cloud side of our architecture?
That's a great question. So we offer in AWS, which is where you can use our cloud product today, and then we are now in early access for our Google Cloud Platform offering. We offer variants that take advantage of NVMe. Those are basically just the way our cloud platform works. Is it uses the underlying compute storage that the cloud vendors offer and turns those into a distributed file system. So you can easily create for example, an all NVMe system in AWS, or you will be able to create an all NVMe system in GCP, which makes a ton of sense for higher performance workloads, there's a lot of, like, if you're training models, that can be a really good use of it. If you're doing like rendering in the cloud, stuff that's really bursty and really fast, where maybe you're not going to use those nodes for very long, but you want to get through a lot of work really fast. That's a great use of NVMe in the public cloud. The other thing I'd add is that we have a customer called FuseFX that uses our public cloud product, and they came to our sales kickoff one year and talked to the whole company, and they talked about the value prop of Qumulo in the public cloud as, quote, turning time into a variable, which was really awesome, because what it meant is that they're able to say, hey, if I want to get this work done in 3 days, here's how much it would cost. If I want to get it done in 2 weeks, here's how much it would cost. And I can turn that dial up or down. And NVMe in the cloud is a great way of turning that dial up and down, because you can get faster or slower performance with code, as opposed to getting stuff delivered in your data center.
Yep. Okay, great. One other question came in. What network infrastructure is recommended for all flash? And really talking about the performance slides that we showed. What kind of networks do you need to run on to get that? Is it 40? Is it 100 gig?
Right. So we offer, first of all, just to be clear about this one, we believe in Ethernet. We believe in simple. So it's all Ethernet based. We don't really do any like fiber channel work. And it's all super simple. You just buy nodes, put them in a rack, plug them into a switch. They find each other, cluster, and off they go. The all flash product uses a 100 gig switch. You can step that down if your networking isn't ready for 100 gig, but we made a decision to make those, the network cards in those boxes be 100 gig ready, just because it felt like that's where the world is going, and that's what it does. We have lots of customers that use that step those down into various other levels. Increasingly, we're seeing a lot of 25 gig out in the world. Obviously, if you put the fatter a pipe you put in, the more performance you're going to get out of the product. So, to the extent that you're able to use higher end connections, you'll get more performance from the product.
Okay, great. I think that's it for questions. Ben, thank you for jumping on and sharing kind of the strategy thoughts behind Qumulo. One last question. Don't go yet. For NVMe network, do we require RDMA, and which one?
We do not require RDMA. So the answer is no. The simple reason for that being that most customers so far have not. There are definitely some customers and environments that have implemented RDMA clients where you can get where you can take advantage of that. Sometimes people will call that RDMA over fabrics, for example. But most customers haven't done that for most of their clients yet. So we made a decision not to require that in our product. That's a pretty pricey thing to do for your clients. And the other is that sort of would run counter to the strategy we're trying to do, which is to sort of democratize flash and put it into the hands of more people. It looked like there was another question hiding in there.
Yeah, there was. They're trickling in. So the question was more about collaboration. So are there use cases where customers are using Qumulo for collaboration across on-prem and cloud-based Qumulo?
Absolutely. So there's really there's two ways that happens. First of all, data movement between on-prem and cloud is really simple. You create a replication relationship between your on-prem, a directory in your on-prem cluster to your cloud cluster. And you can either do that one time and just move the data up, or you can keep it in sync. So you can, and then we call that continuous replication. It just watches for changes and moves just the delta blocks up. So that's how data movement works. You can also do that from cloud to cloud or from cloud instance to cloud instance. So some examples of how customers have used that. The first is a truly hybrid workflow where ingest happens on premises and then work happens in the public cloud. So you can imagine, for example, I'm capturing data from cameras on premises or from machines, and then I take subsets of that data, I move that to the public cloud, and I do large-scale compute against it, and then I use replication to move the final product down. That's a good example. The other would be this is actually pretty common in M&E, and we're seeing it more and more, which is I built an entire set of workflows on premises in this one area, let's say North America. Now I'd like to expand, but I don't want to build a whole new data center and infrastructure in this new area. How can I expand this workflow into, for example, Europe without building a European data center? Well, the public cloud is a great use for that. So what we've done is partnered with groups like Teradici and others to enable you to build an end-to-end cloud workflow so that you get storage, desktops, compute, and all of that together in the public cloud. And then you just move data from an on-prem array to an entirely end-to-end cloud workflow. And we sometimes market that as Cloud Studio. So, for example, I want to open up Studio in Europe. How do I do that without any capex? That would be how I do it. And then I can move data back and forth between my Cloud Studio and my on-prem studio and enable collaboration.
Okay, perfect. All right, I think that is it for questions. Really appreciate your time, and everyone who dialed in, thank you for taking the time to sit with us. And if you have any other questions, we're happy to talk to you directly. And have a great week. Thank you.
Thank you.